So before we get into too much else, let's go ahead and look at naming of arrays and the way it is that we signify the data that's loaded into an array. This can be found on pages 89 and subsequently 101. The difference between the two of these is how many different dimensions there are to the array. So 89 has a single dimension array, and we'll get into multi-dimensional arrays a little bit later. So let's get down to the brass tacks here, shall we? So what do we do when we want to signify that something is an array? I have a group of names. These names are all related, and that's what makes them homogeneous. They all relate to a single central data idea. So names of students, names in a classroom, whatever. So I would have benefit by putting them all in an array. So rather than have to say names 01, names 02, names 03, and have, potentially hundreds of different individual variables for that, I can simply make all of that easier by having a names array. And the ellipses, the open and close parenthesis, is the way that we actually signify that. Now, again, I'm not going to get into an argument here about, well, but my peculiar runtime language uses, an open and a close bracket or brace or blah, 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 blah. Yeah, maybe that's the case. But to keep it as universal as possible, we are going to use the open and close parentheses here, and then you can worry about mapping that to whatever your peculiar runtime environment is. So line number 9 there creates for us an array of names, and probably that is going to be strings, but it's pseudocode, so we don't necessarily go ahead and declare those. So the question here is, how many names do we have in that array? Now this is actually where the text doesn't particularly do justice to the reason we would state how many names are in an array. So let's just walk through a use case scenario really quickly. Let's say that here at RVC we have a max classroom size. And that maximum classroom size is capped at 30. So that means no matter, now I understand that there are going to be, rules are made to be broken and all of those things, but the more rules you let be broken, the more likely it is that you are going to allow bad data, and when you allow bad data, you allow inconsistent decisions to be made. So what I am saying here is, as a business, we are going to use the data structure of a names array to help us maintain a business decision that classes are capped at 30. So what we would do is, at the time of declaration, we have names as an array. We can suggest that this is going to be 30 elements large. Now, each of the items in an array is referred to as an element. It doesn't matter what kind of data type you have in the array. So if you have strings, if you have integers, if you have images, etc., it doesn't matter. Each individual part of the array is referred to as an element. So now that I have an understanding of what is going into my array, a set of elements, I can look at what that's going to look like and a couple of key takeaways about the array data type. So if I come over here to my middle tab, I have a 30 element names array. That, technically speaking, would be over there at the far left hand side. I start with Donovan Villa and I end with Eden Russell, and in between there are 28 more names, all of which signify an individual student, right? So Donovan Villa is one of the elements in my array. Kenny Porter is another element in my array. So all said, I have 30 elements. One thing to note here, in Sublime, the default for line numbering starts with 1. With arrays, the default for numbering does not start with 1, it starts with 0. In array, when you show the number of elements, you'll actually refer to them as n minus 1. So if the first element in the array, this one, number 1, Donovan Villa, would really be 0. Down here, Kenny Porter would really be 1. Down here, Tegan Wiley would really be 2. Now, the reason for this is every storage location was precious. Storage actually was far more expensive than processing in the very beginning of the data and programming and computing processing days. Both of these are so incredibly cheap now, it almost seems quaint. But all of our C-based languages, or all of our languages derived of any of our original languages, start at 0. The text does not require, and actually the examples in the text you will notice start at 0 or 1. I will not, because the text kind of pendulates between 0 and 1, I will not force you to use one or the other, but just make sure that if you use 0, you always use 0. If you use 1, work with the user. Are you really ever going to ask a user to enter the 0th element or enter element number 1 when the user's going to have to say to themselves, Kenny Porter's number 2, you had me enter Donovan Villa already. I can count your program's the one that's wrong. Well, you're both right in your own way. But as a developer, it's always your job to make the user the most correct here. So even if you start at 0, 1, and 2 when we're referring to our first, second, and third element in our array, you do the math there, you do the conversion, so n plus 1, n plus 2, n plus 3, or whatever the case may be. So that way you are being consistent in a way that makes sense for what the user is expecting. So now we have a little bit of background as to how to name an array, how to size an array, and how the numbers, the individual elements in an array, are numbered. So we're still going to work with this idea that we have a business decision that we have made. As Rock Valley College, we are saying that we will have no more than 30 students in a classroom. So what, again, we have done is we have created a names array, and we have said that in this array there will be no more than 30 names. So with our previous example, we had exactly 30 names. So that means the entire array was full of data. Now, data reflects the real world in that rarely, if ever, are we going to get a perfect amount of data to perfectly fill our data elements. That's just not the way that this works. So most of the time, what you're going to find is that we're not going to have exactly as many data elements as we have size for our data structure. So this would represent something to that effect. This would be an array that is populated with names that has, that's better, that has 12 elements from June Bauer to Annalise Baker. Now, what happens with all of these extra data elements? So this is really what the array would look like. It would not, simply because we have fewer names, it would not take up less space. Once we have declared that an array has a size, in most good, upstanding, modern compile and runtime languages, it is going to take up as much size as is possible so that it can take as many different data entries as is required. So what we would see is what we see here. Empty, 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 18 empty elements in our array. But really, are they empty? So these do not have, as I'm demonstrating here, zeros in them. 0 is actually a piece of data. These would have in them what is referred to as a null. A null is, it's N-U-L-L, just in case that sounds like a null. It is a space null. A null is it's a marker. It's a marker that designates that there's nothing in here, but in fact there is something in there telling you that. 0, on the other hand, is actually a value. 0 has, mathematical implications to it that null does not have. So we would not see zeros here. We would actually just see null markers. And this array, despite the fact that there are only 12 names populating that array, would still, at runtime, take up as much space as a 30-element array, because that's how much is going to be required of it, potentially. So is it okay to have fewer elements in your array? Yeah, absolutely. The system is perfectly okay with that. Now, the other example of this is when we have too many elements in our array. So here we have an array that starts with Cale Becker all the way here at number 1. And as we keep scrolling down, there are 300 elements, a little more than what you can see here. And that comes all the way down to Kyson-Weber. So we have 300 elements being populated into our array. The question here is, what happens after Layla Pennington? What happens to all of these other names that don't fit within the bounds of the array? The answer is, unless there is shenanigans. Now, there is no magic, remember, in computer science. There is no magic here in data sciences. If you were to have an array that here after Layla Pennington would simply take more of these names as we're entering them in, there has to be processes in the background that resize and restructure this array. That does not happen automatically for you in every programming language, and I am not going to pretend as though that happens for you. What I will tell you is it is much safer to assume the worst case scenario, which is what happens in Java, which is what happens in C++. Anytime you have a 30-element array and you are looking to populate it with more data, 31 pieces of data or more, the following is going to happen. You are simply going to lose that data. It doesn't go anywhere. It is not caught by the system. You are not going to receive notice that the system is experiencing a condition where you have an array that is of size 30 and you are trying to read 300 elements into it. You're not going to get any of that. It is simply going to proceed until the loop structure that you have provided returns false, and it's going to simply proceed to whatever the next bit of code is going to be. You will not be made aware of this. So this is important to understand. One thing you should get in the habit of doing, or at least conceptually in the habit of doing, is making sure that you have some way of testing this. If you know that you have an array of size 30, give yourself another method to test that. Use a counter and say, this many data elements were read into the array. That way, if it says 12 data elements were read into the array, perfect, I have space for 30. If it says 30 data elements were read into the array, well, that was close, but it still fit. 31 data elements were read into the array. Crap. Now I know that my logic needs to be expanded a little bit so as to accommodate that extra data element. 300 data elements were read into your array. Okay, hold on a minute. We are getting much more data than I expected, and logically we have to go back and look at that algorithm and do something about it. So having too little or exactly the right amount of data into an array is perfectly okay. having too much data read into an array simply does not read data into that array. It simply vanishes. It disappears. It is uncaught. It is unrecoverable, and you cannot recover from that without having, a tremendous amount of additional algorithmic logic on top of that. So now that we've looked at what happens when we name an array, so in this case it's names array, we have looked at what happens when we size an array, when we specify exactly how many the maximum number of elements can be in an array. We have populated an array with exactly the correct number of data elements. We have populated an array with fewer than maximum number of elements, and we have populated an array with more than our total maximum allowed number of elements. There's just a couple of small items to clean up on, and that is indicating specifically which element of the array you are looking for. We are going to, via the regular chapter 7.1 podcast, we're going to look at exactly how it is we would use a looping structure to go through and read or populate an array. But before we get there, I just wanted to take one last side sortie here and talk about what we do when we are trying to identify individual elements of an array. So here we can suppose we are looking again at our names array. We have set aside 30 total string data elements to populate into our array, and because it's the very first one, the very first tab right next to my original tab, this will be the data in the array that we are pointing at. So when it is that we are looping through our array, when it is that I refer to names at element 0, this is really referring to June Bauer. So when I say element 0, that is going to map to the data element 0. The data contained in data element 0 is a string, and that string is June Bauer. When I look at names at element 1, that is going to map to a different data element. That's going to be Frankie McIntyre. So again, Frankie McIntyre is not names element at 1. It is the data contained in names element at element 1. So it's just a side sortie to be more concise, I suppose. So when it is that you declare an array, you declare it with its total size. Here, when it is that we are referring to a given element in an array, we would refer to it by its element number. And remember that most shops will have you start your array indices at 0 as opposed to your array indices at 1. And really all you would have to do, if you are using, loop, if I could spell, loop counter to loop through and iterate through your array, we would have names at loop counter +1. This way, the first time through, we start our loop counter at 0. That still maps to the 0th element in our array. We're still able to put data into the 0th element of our array. But when we are outputting something to the user, loop counter +1, that starts at 1 for our user. So remember, that little bit of gymnastics, that logical gymnastics that maps loop 0, element 0, which is really the first one, to the first, I'm going to say verbal, but here it's printed, right? The way we would verbalize the first element of our array, that is your job as a developer to get right. And it's these little things that really make your development unusable versus perfectly acceptable and usable.